guys, it's Aaron and Julian here, and in this video we'll be going over the basics of impulse and momentum. But before we get into the relationship between the two, let's review impulse and momentum separately, starting with impulse. Impulse is a force acting for a given amount of time. This force can change an object's momentum on impact by increasing the time of collision. Now, according to Newton's second law of motion, force is equal to mass times acceleration. This can also be written as force is equal to mass multiplied by the change in velocity over time. Now, do you guys see the equation underneath that squiggly line on the board? If you were to multiply both sides of this equation by t, you would end up with the new equation. Force times time is equal to mass times the change in velocity, i.e., in basic terms, impulse is the equivalent of the change in momentum.
When thinking of momentum, think of an object. This object has mass and velocity, so it has momentum. To change the momentum of this object, you would need to apply some type of force over a given amount of time. The force over time will create a change in momentum because these two are equivalent. Think of a bat hitting a baseball. That will change the ball's momentum. This is because an object has a starting momentum, and after a collision, the impulse can change the momentum. Before the impact, each object has its own velocity. During the collision, the object exerting the force transfers its velocity to the object with momentum, thus increasing its velocity and changing its momentum.
Here's an example of what happens during the collisions of a pool ball, a tennis ball, and a brick wall. The tennis ball is softer and more bouncy, which is great for absorbing impact. The pool ball is heavier and harder. Because of this, both balls have different impulses. If you were to roll both balls using the same amount of force at a brick wall, you can see that the pool ball does not bounce back towards you as much as a tennis ball does. Let's look at a rough sketch of these collisions. The tennis ball drawn in purple is slightly squished against the wall, showing its absorbing of the force of the impact. The pool ball drawn in red does not absorb much impact because it cannot flex. It is much too hard, so the time of the impact is much faster. Alright guys, here's our last example. So let's say someone throws a soft bouncy ball towards you. Before the ball collides with your tennis racket, it has its own constant velocity. During the impact, when you exert force upon the ball in order to hit it, the velocity of the ball changes. It increases. This change in speed occurs because the ball absorbs the force of the hit, but since the force is greater, it makes the ball accelerate. That acceleration is the change in momentum.